we haven't yet discussed the question, but for your early information, so your second test will involve the coal, not the coal. This one I think is actually heat combustion. Heat combustion power generation. Okay, and the second question is uh, transmission line, because this transmission line will be covered next week. Okay, transmission line, which is a short line. Okay, so actually the transmission line, we divided into three type of transmission line. We have a short line, which is less than 80 kilometers, and then we have a medium line and also a long line. Okay, so for this test two, we only assess you on the short line. So short line is actually a very simple and straightforward theory. Okay, so I think we don't have any problems on the transmission line after this. Okay, the only problem that may requires your full attention is this topic lah, the thermal power stations. Okay, which is we will discuss one example from the slide, which is additional self study question. We have two questions. I don't know where this question come from. Maybe from the previous final exam and so on. Okay, and after this, I think I have recently got some books that very good for you, which is the author is Mehta. I think B Mehta from India. So this is actually this book, right, wrote by this person, is a very old book. Okay, so I have recently get the soft copy. Then I will share it with you after this. Okay. So in this book, it has a lot of informations about the power generation, transmission line, and so on. So I think for exercise, so it's a good also alternative to refer to this book. But please be careful, because this book is a very extensive in terms of its contents. So that's why sometimes, so actually the some of the content is actually out from our syllabus. Okay, so you need to be careful on that. Okay, so let's see 2.1. I think this one I have already shared the pre-recorded video on the solution, but if I think we make discuss this. If you have any uh, something that is not clear, then you can just maybe message me or through this chat room. Okay, so let's try the 2.1 first. Uh, okay, 75 megawatt thermal stations. Okay, use coal. Okay, in Malaysia is arang batu lah. Okay, with calorific. Okay, so as mentioned before, for the heat we are using, we measure the energy in calorie. Okay, so this coal with a calorie value of 6,400 calorie per kilogram. Okay, and for the thermal station, we have two two conversion, two energy conversion, which is from the heat and also from the heat to the electrical. Okay, so if I draw this one, this one is actually from your coal from the input. Okay, and then we have what we call thermal and then electrical. Okay, so this is the input and this is the output, and from the output thermal, it will be converted into electrical. Okay, so the thermal has only efficiency of 30%, and the efficiency for electrical, okay, conversion from the output thermal into electrical output, the efficiency is around 80%. So this is what it means. Okay. So the question is calculate the coal consumption, meaning that how many coal that need to be burned, okay, need to be burned up for every hour. So if the station supply its rated electrical power, okay. So you need to carefully read all the sentence because each sentence has information, a very um, big information there. Okay. For example, this one, every hour. Okay. So what you need to do is to know that the relationship between the calories and also the kilowatt hour. So as mentioned before, you have 1 kilowatt hour is equals to 860 calories. So meaning that if you burn the coal, okay, and then the coal supply around 860 calories, so it is actually equivalent to 1 kilowatt hour. Okay, so the energy. So, but if you refer to the sentence here, for every hour, meaning that you are, so actually the answer here is actually hour base in 1 hour. So this one, as you can see here, is this one is 1 kilowatt multiplied with hour. So this one is equal to 860 60 calories. Okay, since we are only concentrating in 1 hour, so we can actually write down this one, the equation is equals to 1 kilowatt is equals to 860 calorie. Okay, because right now we are calculating based on hour base. Okay, setiap jam every hour we calculate what is actually the amount of the coal that need to be burned. Okay, so this is a very important one. So if you have this sentence, calculate coal consumption for every hour, so you can actually simplify this equation by writing this one. 1 kilowatt is equals to 860 calories. Okay, so right now this station is supplied at its rated electrical power. So its rated electrical power meaning that this one. So meaning that it produces 75 megawatt. Okay, it produces 75 megawatt. So from here, you can use this equation, which is the output power, output electrical over output thermal, which is equal to 0.8, right? 0.8. This block. Okay. So it's equal to 0.8. So you can see we use this equation. Okay. So but right now the power is actually 75 megawatt, which is electrical power. So right now we want to have its values in calorie. So what is the equivalent of the calorie here? Okay. Please be mentioned that 1 kilowatt is equal to 860 calorie. Okay, to get what is the value of the calorie, okay, you need to multiply with 860. But please be noted that this is 75 kilo, okay, 75 k, not 75 megawatt, because 1 kilowatt is 860. So that's why I just multiply 75 k. Okay, because 860 is equals to 1 kilowatt. Okay, I hope you get this, because sometimes because you may ask me after this one is 75 megawatt, but why doctors actually multiply 75k? It should be 75 megawatt, right? But you need to look at this relationship. Okay, this is actually 1 kilowatt equals to 860 calories. So inside 75 megawatt, it has how many calories? Okay, so that's why I just multiply with 75k. So you should have the answer is 64.5 mega calories. Okay, so this is actually the output power, the output electrical power. Okay, but in unit of calorie. Okay, so this one is actually is equals to how many that you have calculated? Okay, 64.5 mega calorie. Okay, so this is the output. This is in electrical energy. Energy. Okay, so we converted into calorie. So equals to 64.5 mega calorie. Then from that, we use these equations. Okay, 0.8 is equals to output electrical energy, which is we have already calculated 64.5 mega calorie. Then we got 0.8. Then from that we can obtain our what is the output from the heat, the thermal conversion here. Okay, so the output from the thermal conversion is around 80.6 mega calorie. And from that, this one is 80.6 mega calorie. Okay, so you and then 80.6 divided by 0.3, so you will obtain this input. What is the value of the input in calorie? Okay, so this is actually the input for the thermal conversion. Then you, from here, I think, from this information, this coal, okay, this station, this thermal station can generate 6,400 calorie per kilogram of the coal. So from that, you divide by this one. So you will obtain the amount of the coal that need to be burned up to get this calorie input to the thermal converter. Okay, so it requires around 42 ton, okay, 42 ton, okay, to generate the 75 megawatt of electrical energy. Okay, so one of your friends just asked me in the chat room, kilowatt and kilowatt hour is the same or what? Okay, actually yes, kilowatt and kilowatt hour is not the same. Kilowatt is actually power, while kilowatt hour is actually energy. Okay, is actually energy, because power multiplied with the time. Okay, that's why you got the energy. What I mean, why I actually ignore this, because ignore this one is 1 kilowatt hour is equivalent to 860 calories. Yes, okay, but you refer to the question that I have already highlighted before. Okay, so this is actually calculate the coal consumption for every hour. So every hour meaning that you can actually ignore this one, because uh, this is because we are calculating in our base. Okay, so that's why I always, you need to refer to this question very carefully. Okay. Um. Yes. Okay. You can. There is a question from your friend. Is it okay if we mention the amount of coal needed in unit kilogram instead of ton? Okay. Yes, you can just leave it your answer in kilogram. But if the question give you this one, this information, then I think you need to convert it into ton. Okay, what do you mean by this formula must use calorie? This formula must use calorie. I don't get that. We use calorie because this is the thermal power station. Thermal power station where the input to generate electricity come from the come from the actually the burn of the coal. Okay, so usually the heat energy is measured in calorie. Okay, yelah kalau you burn the energy kan from your body, for example you jogging, so how many calorie that you have burned, so actually heat. So actually we measure the heat energy in terms of calorie. Ada tak ukur kalori yang dibakar unit watt? Macam kelakar pula kan? Okay, how many watt that you have burned today? Okay. So for heat, we are using calorie. So that's why we need uh, this relationship. 1 kWh is equivalent to how many calorie? Okay, because the question is how many kilograms needed. So the relationship between the coal and the energy that it produces is in calories. So that's why we need to convert all our electrical energy into the calorie. Okay, I'm still not clear why use 75 kilowatt instead of 75 megawatt. Okay, so yeah, so I would like to uh, ask you back, how many kilowatt hour in 75 megawatt? 75 megawatt, how many 1 kilowatt is inside this 75 megawatt hour, tak payahlah, because this one is in hour, right? So we can ignore this hour. So I ask you back, in 75 megawatt, how many you have 1 kilowatt hour? 1 kilowatt, sorry.
75
How
kilo.
many 1 kilowatt that you have in 75? Yes,
75 kilo.
75 kilo. Right? 75. Yeah, 75 kilo. So that's why, because this one is actually 75, this one is actually 860 is actually equivalent to 1 kilowatt, right? So that's why you just need to multiply with 75k. Because this one is actually 75k is actually not 75 kilowatt. This is 75k inside this 75 megawatt. Okay. Okay. So how many 1 kilowatt in 75 megawatt? So you have 75k times, right? 75k kilotimes. So, and then multiply with 860 calorie. So that's why, so meaning that you have 75 megawatt is equivalent to 64.5 mega calorie. Okay, that is what it means by this one, 75K. Because 1 kilowatt is equals to 860 calorie. So right now, your power generator generate 75 megawatt. So right now, I want to know how many calories. Okay, so to get the calories, we need to go back to this relationship, 1 kilowatt. So I want to see how many kilowatt inside 75 megawatt. So from here, we can see that inside 75 megawatt, I have 75 kilo times of 1 kilowatt. Okay. So that's why this one 75K multiply with the calorie in that actually represent 1 kilowatt. I hope that answer your questions. Okay, I think I need to maybe erase how to. Yes lah, I want to erase. I just want to make it clear more on this 75 kilowatt and so on. If example, I have 1 watt is equal, for example, is equals to 2 calorie, for example, 2 calorie, okay? So right now, what is, how many calorie in 20 watt, for example, right? So this one, you just multiply. So because we know 1 watt is 2 kilowatt, 2 calorie. So 2 watt multiply with 22 calories, right? So you will obtain this one is 40 calorie, right? Which is simple, right? Okay. So right now, I hope you got this one. Okay, 1 watt is 2 calories. So how many calorie in 20 watt? So you just simply 20 watt multiply with 2 calories, right? So you will obtain 40 calorie. But what if the information here, this one is 10 watt. 10 watt is equal to 2 kilowatt. What is the value of the calorie for 20 watts? How many calorie in 20 watt? The answer should be 4 calorie, right? Right? Because I want to see right now how many, to get 4 calorie, how many 10 watt inside 20 watt? How many? Yeah, 2. 20 over 10, right? So only 2. And 2 and then multiply with 2 calories. So that's why you have 4 calories only. This is actually, go back to this one. This one is not 1 watt equal to 860 calorie. This is 1 kilowatt. So I want to know how many 1 kilowatt inside 75 megawatt. Okay, it's actually referred to this one. Same. Just now is 1 watt, right? 1 watt is 2 calories. But right now, this one 10 watts. So how many 10 watt in 20 watts? So only 2 times. So that's why. Okay. So I hope you need to always remember this one. This is very crucial because if you got this one wrong, okay. For example, you multiply 860 multiply with 75 megawatt, so it is totally wrong. This is 75K. I haven't mentioned units here because this is only is actually 75K. Okay, 75K times of this one. Okay, and then what's okay? What is rate of energy? No. Yeah, yeah. As mentioned before, okay, please be noted that watt and watt hour is not the same. Okay, watt is actually the power, which is 1 watt is equal to 1 joule over second. Okay, so meaning that 1 joule is equals to 1 watt multiplied with second. Okay, that's why the energy, this is energy, is equal to watt multiplied with time. So in electrical power, we are using time not in second but in hour. So that's why we use watt hour. Okay. So just to clarify that you can use 1 kilowatt hour and then 62, but this one after at the end of the question, the answer here, this hour will be cancelled out because you are actually calculating in hour. Okay, so everything this one is actually 42 kilogram is actually 42K kilogram is actually the amount of coal that need to be burned up to produce 75 megawatt hour. Okay, but since we are only 1 hour, so you can just write 75 megawatt. You can cancel the hour. Okay. Okay. I hope that one clear. If you not clear, then you can just reach me. Okay. Okay. So 2.2, a 60 megawatt thermal station has overall efficiency of 30%. So if the coal for the station has an energy of 6,950 calorie per kilogram, so calculate the coal usage per kilowatt hour. So actually itulah this kilowatt hour and then coal calories and so on. You need time to adapt. Okay, before this you will only concentrate on the voltage, current, emitter, ampere, voltage, impedance, and so on. But suddenly, we jump to a topic that totally new parameters. It's actually not new parameters, but it is actually not so oftenly used in our electrical energy syllabus. Okay, so I think that's why we some time to adapt. Okay, so a 60 megawatt thermal station has an overall efficiency, meaning that you have electrical and thermal. So right now it is combined, so it is the overall is 30%. If the coal station has an energy of meaning that the station can produce 6,950 calorie per kilogram. So actually this value is not fixed. Okay, these values is depends on the station. As you can see, this station is able only to produce 6,400 calorie per kilogram. Okay, and this station is able to produce 6,950, meaning that it can convert. Okay, it can convert the energy from the coal to a value, to a some value. So this one is 6,950 calorie per kilogram. Okay, so calculate the coal usage per kilowatt hour. Okay, what is the coal usage per kilowatt hour? Okay, a 60 megawatt thermal station has overall efficiency of 30%. If coal for the station have an energy, calculate the coal usage. What is the kilogram? What is the weight of the coal to for every 1 kilowatt hour output? Okay, so you have the equation, the output electrical over input, okay, in calorie. This one is in watt. Okay, so this one is equals to 0.3. Okay, and we know that 1 kilowatt hour is equal to 860 calorie. Okay, so right now you can, by using this equation, I assume that the output power is actually 1 kilowatt. Okay, 1 kilowatt. So this one is 860 calorie over the input is equal to 0.3. So right now I can obtain my input is equals to 860 over 0.3. Okay, berapa Can someone calculate for me? Okay, one of your friend asked me. Yes, we can cancel the hour because it is uh one. Yes, because every hour. This is hourly base. That's why we can cancel. Okay, because this is 1 hour base. Okay, so can someone just calculate for me the input? So okay, so meaning that the input, this is 2866.67 calories. Okay, so this is the input. Actually, the heat, okay, from the uh, combustion of the coal. Okay, so right now this is the energy from the coal, from the burning of the coal. So it's 2866.67 calories. Then from that you have this information. Okay, this station can generate 6,950 60 calories per kilogram. So from here, so the amount of coal is actually 2866.67 over 6950. This one per kilogram, KCL per kg. This one is actually KCL, right? So you can actually uh, calculate it. So you will obtain the values is 0.413 kilogram. Okay. So I hope you got you can calculate and get the answer 0.413 kilogram. This one, the solution is already here. Okay, so you can refer back. So this one, I just want to discuss how the solution is made. So next, okay, this is very crucial also. Right now, this is the question is coal usage per day. Per day. How many coal that need to be used to generate electrical output 60 megawatts. Okay, 60 megawatt per day. Okay. So the amount of energy 60 megawatt hour multiply with 24 hour. Okay. You should get how many? Sorry. This is not hours. 24 megawatt. Okay. So 60 megawatt. This one is actually 1 hour. So you need to multiply with 24 hours. So how many hours? So how many megawatt hours? One four four megawatt hour. Okay. So this is energy. 144 megawatt hour. Okay. So this is actually the amount of for 1 day. So 144 megawatt hour. So how many calories? Equivalent to how many calories? You should use this formula. Okay, 1 kilowatt hour is equals to 860 calories. So 144 megawatt hour, how many calories? Okay, to get that, you need to 144 megawatt hour over 1 kilowatt hour. So this is equals to, this one should be K. So 144 K, right? So 144 K multiply with 860 calorie. So you should get around how much? One four four. Is it 144? No, I think 144 K. Okay. So 144 megawatt hour, you have 1440 K. So and then multiply with 860 calories. So is it 1.2384 giga? Giga is actually giga. Giga berapa eh?
That's 109.
10 of
9.
9.
9. Yes.
Okay. Calories. Okay. Balik pula. This one. Is it correct? This one. This one 6 mega. Ayolah 60k lah. Okay, multiply with uh, the answer is 4132. Balik pula. Total energy. But this one okay dah.
Kenapa dia darab dengan 2.8 something?
2.8. This
Ah,
one is actually this one from here. Sebab dah kalikan kat sini.
oh,
This
so
one is actually coal yang this one dia dah orang kata apa dah bahagikan lah dengan 0.3 kan. So this one is actually the calories from the power stations lah to produce this one. Sebab dia dah kalikan dengan 0.3 ni.
so
Benda sama je
kita
rasanya.
sepatutnya kena darab dengan yang
So
tu
berapa
lah,
you
bukan
dapat
darab
this one?
dengan
Input.
860.
Bendanya sama je. Bendanya sama je. Sebab saya, I think this one I just simplify a little bit. 60 kilowatt energy from the coal to produce 1 kilowatt hour. Actually, this one come from the energy from the coal to produce 1 kilowatt hour. Okay, so this one is actually you multiply with dia punya with the efficiency of the conversions, right? Okay, so it requires around 8.8 2.87 kilocalories to produce 1 kilowatt hour energy ataupun 860 calories. Okay, so this one lah. So this one the output, and then you need the output power 60k. Okay, instead of 60 megawatt, you need to just use a 60k multiply with the hours 24 hours, and then multiply with the energy from the coal kat sini. So that's why you can dapat 4132.8 meg. And then from here you can get lah the answer. But I think if we proceed like this, because I don't have my calculator, I forgot to bring it. So I will try to calculate it. I think you got the same answer actually, but this one is longer solution here. Okay, because but I hope you understand this why. Okay, so 60 megawatt 24 hours is actually 144 megawatt hours, and inside 144 megawatt hours, how many calories? Okay, equivalents. So which is we have calculated. So 1440, right? 1440 K. Okay. So this one and then multiply with 860. Okay. So you count dapat 14 bagi berapa Fikri? 0.3 tu bagi berapa?
1.238
This one
giga tu.
Okay,
Dia,
yes. Bagi
yeah.
0.3 you will get 414228, right? 28
Yes.
mega calorie, right?
Very yes.
So this is the input lah. So this is the input, the heat lah from the burning of the coal. Okay. So from that, you divide this one. Okay, so the amount of coal, okay, so 4128 mega calories divided by 6950 calories per kilogram. So I think you should get the same answer. Okay, because one of your friends privately messaged me that he got the same answer. Can someone calculate? Yes, okay, yes, thank you. So 4128 mega calories divided by 6950 calories per kilogram, you should get the same, which is 858 kilograms. Kilograms. Okay, kilograms. So we want to avoid 585K, so that's why we just put 585 ton. Okay, because 1 kilogram is equals to 1 ton. Okay, thank you very much for your friends. Itulah yang bantu ni. Okay. Okay, I hope you understand this one, how and so on. Okay, I think we stop here. Okay, and next week on Sunday. So Sunday is not holiday because for Johor, if the Christmas right now, the Christmas is actually on Saturday. So for Johor State, there is no replacement. So on Sunday we will continue our class as usual. Okay, but for the first 1 hour, we will discuss on the example section for the hydropower plant, and then after that, I will leave you to watch on the transmission line, which is the short line and medium line transmission. So we will go for new subtopic, which is the power transmission next week. Okay. So I think that's all from me. Thank you very much for your cooperation throughout this class. Okay. Uh, uh, any questions before we dismiss this class? After this, just watch. I think maybe you can, if you have already the pre-recorded video about the hydropower plant, then you can have your relaxed time. Okay, but if for those who still didn't watch the hydropower plant, then I think you need to proceed with that, because after this next week we will only discuss some examples. Okay, and then after that we go for the power transmission. Okay. Okay. Voltage regulation. Voltage regulation. Voltage regulation. Do you mean the transformer? Because in transformer also we have voltage regulation and power transmission. Actually, for general voltage regulation is there is no units because it is a ratio. Because it is a ratio. Okay. There is no unit. Oh, I forgot. Okay. I hope you have already submit the first assignment. Okay. And maybe after the second test, there will be a second assignment, which will be on the power generation. I think more on renewable energy. So I will give you the topics. Okay. Every group will have one topic, one different topic need to be discussed and chosen and submit as an assignment. Okay, so I think that's all from me. Thank you very much. So Assalamualaikum. Have a very good day.